Clearing fractions is a method for solving equations when there are fractions in the equation. So normally we look at an equation like this and we think, I could just change those to common denominators so I can combine the two fractions on the left side. And that's true, you can do it that way. But there's something different you could do with the common denominator that'll get rid of the fractions in the equation. Here's what I mean. The common denominator for 5 and 3 would be 15, right? Let's multiply the entire equation by 15. We distribute the 15, so think of it as multiplying each term by 15, and I'm going to reduce everything I possibly can. Watch this. When I multiply 11/5 times 15, the 5 reduces with 15. 5 goes into 15 3 times, so I'm left with 3 that I still have to multiply by. Next, try the 3 in the next fraction. In -2/3, the 3 cancels with 15 and leaves 5. In 2x, the denominator's 1, so nothing reduces. You multiply by the entire number, 15. So let's do the multiplication and simplify. 33 minus 10 is equal to 30x. And this is what clearing fractions does for you. Now we have a simple equation to solve with no fractions in it. It doesn't have any fewer steps in the process. Most people make fewer errors and can work more quickly when there's no fractions in the equation. So that's the benefit. Let's finish this problem. When I subtract, I get 23 on this side. I still have 30x, so I need to divide by 30. So x is equal to 23/30ths. And that is my final answer, and I always love to set it off by a box or a circle. Let's try something else. The denominators could be anywhere. They could be in every term, one term, two terms, it does not matter. Think about what would be the common denominator for 3x and 5x. You don't want any extra factors in your common denominator. I want the lowest common denominator. So I do need both 3 and 5, so 3 times 5 is 15, but I only need x once. So I'm going to use 15x for my common denominator, but instead of changing the denominators, I'm multiplying by 15x. Now let's see how much we can reduce from every term. The 3x reduces and leaves 5 as a factor. Nothing reduces for the middle term, so I'm going to multiply by the entire 15x. And in the last term, 5x reduces, and that leaves 3 to multiply by. Let's simplify this. So I get 25 here, plus, now when I do 15 times 12, let's do some mental math tricks here. 15 times 10 is 150, and 15 times 2 is 30. So if you add 150 and 30, you get 180. And there, I did not need to bust out my calculator for that one, which I love. 3 times -11 is -33. Okay, let's solve this. I'm going to move that 25 using subtraction. So those are gone. I've got 180x is equal to -58. And I need to divide by 180 to isolate that x. That needs some reducing. I can see that both of those are even, so let's divide by 2 to get started here and see what happens. I get -29 in the top, 90 in the bottom. Since 29 is prime and it's not a factor of 90, we are done. And that is our solution for x. Let's try one more problem. Okay, this one has lots of x's all over the place, no problem. Here's the important thing. When you have a binomial, that is two terms added or subtracted in the denominator, all of this is a factor. You can't break that down into two factors. Same thing here. They're kind of like prime numbers, all right? So I'm going to have to multiply those together to make my common denominator. Here's what I'm going to multiply by. I don't want to multiply that out unless I have to. So let's just leave it like this until we know that we have to multiply those together. That's our least common multiple. So let's start reducing. In the first term, all of x minus 4 reduces with the x minus 4 in the product on the right. So what's left to multiply by is x minus 1. Similarly, x minus 1 reduces and leaves x minus 4. And in the last part, 1 is going to be multiplied by all of that. Now that's a little sloppy, so I'm going to write it out one more time. Now let's simplify by multiplying out what we can. Let's distribute the first term. So I get x squared minus x, and in the second term I get x squared minus 4x, and I do need to multiply this out either using distribution, with the x and then with the minus 4, or FOIL method, or any other way that you know how to multiply two binomials, that turns into x squared minus 5x plus 4. Okay, let's do some simplifying here. On the left side, I've got 2x squareds all together and minus 5x. Nothing changes on the right side for now. A common strategy for solving quadratics when I have this x squared is to move everything to one side so it's set equal to 0. I'm going to do that. So I'm going to subtract the x squared, I'm going to add the 5x, and I'm going to subtract that 4. Let's see what happens next. This is gone, this is gone, this is gone, so it is equal to 0. On this side, I have x squared, and the 5x's drop out, and I'm just left with minus 4. That's interesting. Well, when you have x squared minus 4, you can either factor it, or you can add that 4 back to the other side, since there's no middle term, and just separate the x squared from the number. Then you can take the square root of both sides. But be careful, this always produces two solutions. So x is equal to plus or minus 2, which is the square root of 4. And that is your introduction to clearing fractions. It's a really useful tool all the way through calculus, so I hope you put it to use right away so it becomes something you can rely on.